Okay, so I'll just kind of read the blurb. Guys, quiet, please. Strategies for solving equations. Today, you'll have the opportunity to solve challenging equations. As you work with your team, the goal of this section is for you to apply strategies for solving equations to other types of equations. You'll be challenged to use multiple approaches and the right clear explanation to show your understanding. So one approach would be solving graphically. And we did this in chapter 2 a while ago, was how to find special points of a function. Like, for example, if this is a parabola, well, it is a, that's pretty clear. What point on the parabola kind of stands out? Like that's considered a significant point that we should always focus on? The vertex, totally, right. The vertex is kind of a key point, right? So we talked about that. Also x-intercepts, right? Those are also important too. Which the x-intercepts don't seem very obvious here, but the vertex seems pretty obvious to me. What would you guys say the vertex is for this one? Yeah, that seems pretty obvious, right? So, and consider the following equation that they put boxes. I know this is gonna be a y here and an x here. Duh, right? I know that. So y equals x plus 3 squared minus 5. So how many solutions does it show? It shows 2 solutions. And how's it shown in the graph? As x-intercepts. The x-intercepts are the solutions. Why are they the solutions? That's because y equals 0. Right? When you're on the x-axis, y equals 0. So if you set the equation equal to 0, 0 equals x plus 3 squared minus 5, solve for x, that's going to be the solution to the equation. So that's it, right? That's all you do. Now, part B is asking, use the graph to solve the following equation. How did the graph help you solve the equation? Okay. So instead of actually going through the motions, so if you so desire, and we'll actually do it for 4 too, if you so desire, but if you look at the graph, so there's 2 things, using the graph or algebraically. So here, you're told that y equals that, right? Remember, we told y equals x plus 3 squared minus 5. Also, you're told that x plus 3 squared minus 5 equals 4, right? You're told that. So y must equal 4. Where on the graph does that happen?
Well, what does it mean where on the graph?
So where's y equal 4 in the graph?
Oh, wait, negative.
0, yep. And where else?
Oh, y.
Yeah, not x.
Yeah, 0.
So that happens at 0. Sorry, 0 and -6, my bad. So that's how you can use a graph to help you. Just look at the graph and say, well, yeah, duh. At x equals 0, y is 4. At x equals 6, y equals 4. Boom, got it. You need to know still?
Yeah.
Sorry, because you walked in late. Sorry about that. Here we go. Yeah, not hard, right? Here we go. So you don't have to do algebraically if the graph makes it easy for you. Also, you can do this too. If you just go to Desmos, right? Desmos is good. So y equals x plus 3 squared. Come on, I'm struggling this morning. Here we go. Plus 5 minus 5, and y equals 4. Great. See, -6 and 0. Perfect, right? Looks good to me. But let's actually do this algebraically just to be sure that our graphs, our eyes are not deceiving us, right? So if I do it algebraically, and if I have to do algebraic, I'd have to see the steps clearly. But personally, you know, if you have a graphing calculator or Desmos, yeah, just do it in the calculator. So how would I do this algebraically? What would be my first step? Yeah, because you gotta get x by itself. Good, good. Now this is the part, and in case you're curious how I would score this, I'd make that worth 1 point, right? Adding the 5 over, I make that worth 1 point. What should be your next step here, guys? Square root both sides. I'd probably make that worth 2 points if this were a test question.
Wait, so I got a 0. How are we supposed to find negative?
I'll tell you in a sec. This is why I would make it worth 2 points. So Hunter asked, fantastic question. Fantastic question. You said you got 0, right? So what's the square of 9? Not really 3. It's a half truth. You're not telling me the whole truth. It's plus or minus 3, right? So that's why I'd make that worth 2 points, that process. And then the final answer would be worth another point. Again, if this were a test question, the final answer would be worth another point where you just move the -3 over. So of course, that's -6 or 0. There you go, right? So yeah, that would be like a 4-point problem. That's it. So now hopefully you guys are understanding my grading system, how that works, because as we're moving to finals, which is going to be 37 days from now, it's coming up fast. 5 weeks.
How many points is the final?
20% of your grade.
Okay.
So, but the tests have been about 10-15% anyway, so it's just like a test. But yeah, anyway, let's keep moving, guys. All right. So 4-3. There are 3 general ways to solve an equation: rewriting, so putting in another form, which we did on the test; looking inside, which means reasoning something about the expression that might help; or undoing, which means moving things around. The rewriting makes sense because we did see that on the test that we just had. Again, I can't repeat that because people in this room haven't taken it yet. Undoing, we do all the time. No pun intended, but yeah, we do that all the time. Looking inside, I'm not sure what's meant by that. Reasoning about the value, I guess maybe just looking at it and eyeballing it, perhaps. Maybe, I don't know. But let's look at this one here. This one looks a little crazy, right? X minus 5 4 plus 2/5 plus equals 9/10. So Emily decided to multiply both sides of the equation by 20. So the equation becomes the following. What strategy did she use? She definitely used rewriting. That's for sure. She definitely rewrote the equation because what she's doing is this, right? The equation is still the same. It's still going to be 5 parentheses x minus 5 plus 4 times 2, which is 8, 9 times 2, which is 18. So yeah, that's just rewriting. And how can you tell? You can tell because each side change in the same way. Each side change in the same way. Now, next up, different person, L, took Emily's equation, decided to subtract 8 from both sides. Which strategy she used? So in this case, you're undoing. Because what she did was she added 8, subtracted 8 from both sides, right? So when she had this here, she subtracted 8 from both sides, and guess what? There you go. 5x minus 5 equals 10, right?
Where did the
Cool.
8 come from?
When you did 20 times 2/5.
Okay.
Right. Okay, lastly, Eric looked at L's equation and said, I can tell that x minus 5 must equal 2 because 5 times 2 equals 10. That was looking inside. He used intuition, right? Because he realized, yeah, something times 2 equals 10, right? 5 times something equals 10. So that something has to be a 2. And then after that, realize, oh yeah, then add 2 and you're good. Sorry, add 5 and you're good. So I think you guys naturally do this. I know you guys naturally do this because we've trained this since middle school. You guys have been doing this. The rewrite might be a brand new thing. And that's a good first step to make the equation easier for yourself. So this is huge because if you don't rewrite and make it easier, that's when mistakes happen, right? Or you get stuck and you stare at for like 10 minutes and have no idea what to do. So this is important. You really want to get good at doing this step to move on to the more advanced stuff down the road. You guys do this. I'm sure you guys are fun. This is more muscle memory now. And this is just something that you guys should always be doing. Maybe you realize you don't. It's more subconscious. I don't know. But just kind of good because I do this all the time. Because when I solve an equation, if I sometimes get so caught up in this process, I get so caught in this that I sometimes make a mistake. And when I check over, wait, once that doesn't make any sense, and I have to go back to double check that work. So don't get too caught up in the algebra. Try to make sense of the answer. That's what this is all about. The last step, make sense of your answer. Because if it doesn't make sense, yeah, then like word problems, it would be a great example. Like let's say we'll do trig later on at this. I don't know when we'll do trig, but let's say I give you like a trigonometry problem. You guys actually did trig last year in geometry, and like you're told like, hey, the angle of elevation, blah blah blah. And you gotta use like sine, cosine, or tangent, whatever. And say you make a mistake, and you say, oh, the height of the main building is 1 feet. That's totally bogus. We know the height of the main building is not 1 feet. It's probably maybe 80 or 90 feet. So you also have to just make sense of your answer. That it makes, if it doesn't make sense, then go back and double check your math. So, oh, there's more. Geesh, okay. We're almost done here. Then it's okay. All right. Let's take a look at D here. So how many solutions does this function have? Okay. It looks kind of crazy. Don't let it be crazy. So when it says how many solutions, it means that let y equal 0. So 0 equals all this junk here, right? Well, what is this equation here? What is that graphically? What is that? What would it look like graphically? It's linear, totally. How do you know? Yeah, totally. Excellent observation, Clement. Perfect. It's linear because it's like y equals mx plus b. And also no exponents, right? Yeah, totally. So it's just gonna have one solution. Because lines cross the x-axis how many times? Once. Unless if it's parallel, it's like y equals 2 or whatever. It's like a horizontal line, but yeah, just once, right? Okay, then how can you use the graph on your graph calculator to check your solution? That's easy. Find points of intersection. Find where the line y equals x minus 5 over 4 plus 2/5. Yeah, plus 2/5 intersects y equals 9/10. I'll give you guys a chance to write that down, but that's how you could check. You graph the line right here, and you graph 9/10 to see where they touch. That's what you did. The key phrase is intersects. That's very, very important. Yeah, that's a key phrase, intersects. And then how can you use a table? Oh, I need to plug in. How can you use a table on your graph and calculator to check your solutions? I'll show you right now, and this will be a recording. And then we're gonna forego. I'll tell you what to do for the examples down below, but I won't have you guys do all of it because that just takes too long. Because I want you guys to get head start homework. So how would you use a table in the graphic calculator? Just give me 1 sec. Dropbox. Here we go. Math. Okay. Okie dokie. Let's do it. Plus 2/5 and 9/10. Go graph in the center window. Here we go. So there's your line, right? Easy peasy. There's your line. There's 9/10. Now, do you guys remember how to find the point of intersection? What do? Second, trace, option 5, hit enter 3 times. Okay. So how do I do it again, guys? After you graph, hit second, trace, intersect. Right, there we go. And let me do it one more time. Sorry. 1, 2, 3. You get 7 and 0.9. Great, awesome. Now, how do you do a table? Hit second graph, and there's a table there, right? And what are you looking for? You're looking for when the two y values are the same. The second y value is always 0.9. That's just a constant. So you just keep going until you see it line up, and there you go. They line up right there. So the way you do in the graphing calculator is you its second graph. The second graph, and see where the y values for both equations are the same. That's how you do in the graphing calculator. Desmos, you just go straight and look at it. Easy. And for the juniors who are probably, you got your, so the juniors got your digital PSAT score reports, right, on Monday. And you're going to do the SAT. The sophomores you don't have to worry about for another year. And you're going to do the SAT in the spring. Actually, we're mostly sophomores here, aren't we? Or you're yeah, we don't have, yeah, we're mostly, but anyway, regardless, you could use Desmos, right? You use Desmos on the SAT. That's much better. So, because they ask these kind of questions. All right. I'm not gonna work all these out for you guys, and I don't want you guys working this out either because it's gonna be a little strange, but I'm gonna tell you this right now. These two are no solution. How was I able to figure that out so quickly? How did I know that? Just by looking at the equation. I didn't do it. I did zero algebra. It's not like I have this way brain. Like, let's do all the. Yes, exactly. Yeah, if you move the 2 over, right? If you move that 2 over, then what happens? X minus 3 squared equals -3. How can you square something and make it negative? That's impossible. Same thing here. Absolute value never equals a negative number. That defeats the whole purpose of absolute value, right? That just can't happen. So that's what's happening there.
What about that first one?
No, that will be. I'm not going to do it because it just takes too long. But let me just kind of tell you some hints of what you can do. Like here, I'd multiply both sides by 3x.
Oh wait, I want to add these because I might get upset. Okay.
Right. Here, I'd multiply both sides by 15.
How do you know? You'd like the least common denominator?
Totally, 100%. Right. Here for D, I would FOIL and combine like terms. Here I would do this. Because absolute could equal positive or negative.
Wait, so that one, what would you do?
I divide by 4 and then split into 2 equations.
Yeah, so it would be you either add 2 or subtract 2.
Right.
And then you divide.
Correct.
Oh wait, so on the absolute value, when you change the one that's on the outside.
Right. Right. Yes, exactly. Because it could hold 2 values. B, just kind of undo it. And then finally for this one, for H, this one's gonna be kind of weird, but it works really well. So what if you let A equal x plus 2? So it's a squared plus 4 minus 5. Now factor, and you get A, and then you can come back and get x. But you could graph in your calculator. You can use a table. You can rewrite. I kind of did all these here. I didn't really do these two. I mean, you can, but I chose 3, 4, 5 just using some algebra. I definitely did a looking inside for C and C and F. So I kind of did that for C and F here. Rewriting, I'm doing that for EGH. It looks like A, B, and D I'm undoing. So anyway, just some thoughts how you can do that stuff. So So now you guys get a chance to practice. You guys can do your homework. The homework is I need to hand it to you guys. I didn't attach it this time. And some review of old stuff too. And for those who are doing the retake tomorrow, or maybe some of the time rearrange, I'm going to talk to you guys in a few minutes and I'll give you some practice problems to do. Otherwise, just work on homework and that's that. So we still got another 25 minutes. You guys can toy off this homework out and have no homework. Right. Oh, yeah. Yeah, but I'm going to tell you some questions. Yeah, I'm going to come to. Sure, yeah, totally. So for those that are aiming to do the retake, those are the 5 main topics. Let me create a quick document. It should take about 2 or 3 minutes to do, which I'm going to hand to you guys with the answers, and then we can work through it. So just give me a moment to do that. But those are the topics. So feel free to take pictures of it, if you so desire. Yes, Dave, go ahead. Yeah, go ahead. What the homework? Yes, go ahead.
First one,
Yes.
once you like solve for 0 and 4, you have to plug it back in to get to show that like the other one's one. The Wi-Fi is
Oh, yeah, to verify, yeah. Yeah.
to show that.
To verify, yes. Yeah. Yeah, you plug back into the bigger equation.
No.
What the heck is it? Hold on, guys. Just kind of struggling here. Oh, sandwich. Good one.
Three.
Yeah, go ahead.
What did you get for 480 part B?
I'm just gonna do some in my head. 3, 6, 36, 35.
Yeah.
That's it. There's only one answer.
The
You're not square rooting. You're squaring both sides. It's when you have to square root that you get two answers. You're not square. The square is not an operation you're using
Oh, okay.
in the problem. So
No. That's what.
oh yeah, go ahead. Yeah, far away. Give me 1 sec. I'll be there in a sec with you. Yeah. Okay, I hit all those things. The next one, right? Transformation. Yeah, I'll be in a sec almost, and Dale's will be also.
I'll be good.
Pretty sure. Okay.
Pass on real quick.
Go ahead. Yeah. Check out. Okay.
So if you start with that equation,
Mhm.
or it's over 2, and then this one's over 3. So do you multiply everything to get the common denominator 6?
Oh, I got stuff.